Electrostamping works by trapping composite particles in the electrolyte, forcing them to plate with the metal. With this new technique, high composite particle loadings are possible, even on water-sensitive objects.
Unlike typical electroplating, this technique does not require submerging the object in a liquid bath. Any conductive object, regardless of its size or shape, can be coated with functional materials.
Fluorescent metal composite coatings can have far-reaching applications for dim light environments, including aircraft maintenance equipment location, road sign illumination, and tribological markings of mechanically machined parts.
To begin, weigh nickel sulfate, nickel chloride hexahydrate, and boric acid as mentioned in the text manuscript, and combine them in a vial together. Grind this salt mixture thoroughly to a fine powder. Make sure to use proper protective equipment, fume hoods, and a hazardous waste disposal system. Next, weigh 1.8 grams of europium, dysprosium-doped strontium aluminate, europium-doped yttrium oxide, or europium-doped barium magnesium aluminate, and grind it into a fine powder using a porcelain mortar and pestle for approximately 10 minutes. Combine the ground composite powder with the salt mixture in a container for storage. Weigh 0.188 grams of this mixture per square centimeter of the coating area, and add it to an open-top container. Add 40 microliters of water per square centimeter of coating area to this mixture, and stir to dissolve the salts and form a thick paste.